Hey there, welcome to BrainyHub. Today we are going to learn about an algorithm which is called binary search, and we are also going to learn about its implementation in Python. So let's get right into it. Binary search is a searching technique that we can use on sorted arrays or lists. It is a much more efficient alternative to linear search. For example, if you look at this array, it's an array of values from 1 to 10. You can also call it a list. Now if we wanted to find the index at which 7 is located at, we can do so by just using a simple for loop like this, where we loop through the entire array and then whenever we come across 7, we just return its index. Now this is a simple way to do it, but it's quite inefficient considering that we only have to find the index of the value. So binary search is an alternative to linear search, but it is way more efficient. In linear search, the algorithm takes big O of n time or linear time, where n is the length of the array, meaning in the worst case we might have to loop through the entire array. But in binary search, the algorithm only takes big O of log n time complexity, which is almost half of big O of n time complexity. So it is way more efficient. Now let's look at how binary search works. So we are going to take the same array, which is an array of values from 1 to 10. And in binary search, the first thing that we do is we set two pointers. The first pointer is a left pointer and the second pointer is going to be a right pointer. The left pointer would be at the very start of the array and the right pointer will be at the end of the array. Then what we do is we calculate the middle of that, meaning the middle value between the left pointer and the right pointer. To do that, we just add the left pointer and the right pointer and then divide it by 2, and we remove the decimal place so we get a whole value. Like in this case, if we add the left pointer, which is going to be at the 0th index, and the right pointer, which is going to be at the 9th index, and divide that by 2, we are going to get 4.5, but we are going to remove the decimal, which will make it 4. So we are going to move to the element at the 4th index, which in this case is going to be 5. Now we have to check for a couple of conditions. The first one is we check, is the current value that we are on right now our target? For example, let's say we want to find 5 and our middle value in this case is also 5. So if our middle value and the target that we are trying to find are the same, then we'll just return the index of the middle value. But if not, then we have to check for two more conditions. The first condition is if the middle value is less than our target. If that's the case, then we are going to remove the left half of the array. Now the reason we do this is because if the middle value is less than the target, then all of the values to the left of the middle value are also going to be less than the target due to the array being sorted. So that's why we remove the left half of the array, which just decreases the area that we have to search by half. Now if this isn't the case as well, then we have to check for a final condition, which is the middle value greater than the target? If it's greater than the target, then we are going to remove the right half of the array, because if the middle value is greater than the target, then all of the values to the right of the middle value will also be greater than the target due to the list being sorted. So that also divides the area that we have to search by half. Now to remove the left half of the array, we can implement this in code by just setting the left pointer to be the middle value plus 1. So that automatically removes the left half of the array. And for the right half, we just set the right pointer to be the middle value minus 1, which removes the right half of the array. Now all we have to do is to repeat this process till we find the index of the target that we are trying to find. Now let's see this in code. So let's create a function for our binary search. I'll call it binary search, and this is going to take two arguments. The first one will be the array itself, which is going to be a sorted array, and the second one will be the target that we are trying to find. Now we have to set our pointers. So the left pointer is just going to be at the start of the array or 0, and the right pointer will be at the end of the array, meaning the length of the array minus 1. Now the reason we perform minus 1 is, let's say if we have an array like this. In here we have 3 values, and if you want to find the value at the last index, then that would be at the index number 2, as indices start from 0, then 1, then 2. So 3 is at index 2. Now if we try to find the length of the array, we are going to get 3, and index 3 would be somewhere right over here, which does not exist. So for that reason we subtract by 1, which is going to give us the last element. Now let's create the while loop. So we are going to run the while loop till our left pointer is less than or equal to the right pointer. If that is the case, the loop will run, but if not, then it will stop. So for example, if we have already searched through in the entire array and we are left with the final value, for example 3, then in that case the left and the right pointer are both going to be at the same place, meaning we have ran out of space to search for the target. In that case, the while loop will stop. Now inside the while loop, each time we have to calculate the middle value or the mid, and the way we do that is to add the left and the right pointers and then divide that by 2. So that will just give us the mid value. Then what we do is we check, is the element at the middle of the array the same as the target that we are trying to find. If that's the case, then we are going to return the middle value. So let's say we have an array like 1, 2, 3, 4, 5, and let's say our target is 3. Now when we calculate the middle value for this, we are going to get the value at index number 2, which in this case is 3. Then we'll check, is the value at the index number of the mid, which we already got, which is 2, the same as the target we are trying to find. In this case, yes, the value at the second index is 3 and our target is 3. In that case, we are just going to return the index of that middle value, which is the middle value itself. But if that isn't the case, then we need to check for 2 other cases. The first one is if our middle value is less than the target. If it's less than the target, then we are just going to remove all of the values to the left of the mid, because the array is going to be sorted, meaning if the middle value is less than the target, then all of the values to the left of the middle value are also going to be less than the target. So to do this in code, we are just going to set our left pointer to the mid pointer plus 1. Now let's see how this is going to be done. So let's say we have the same array like this, and let's say that the target in this case is going to be 4. So if we want to find the middle value, it's going to be 3. Then we'll check, is the middle value less than our target? If that's the case, then we are going to update our left pointer, which is going to be at the start of the array, to be at the middle of the array plus 1. So our left pointer would be updated to be right over here, and it will not be here. So as you can see, we have eliminated half of the array, and now we are going to search within this region. This is going to be the final condition where we will check if the middle value is greater than the target. Now to do this, you can just use an else statement, since we have already taken care of the other cases. So in this case, what we are going to do is we will set the right pointer to be mid minus 1, and that will eliminate the right half of the array. Now this loop will run till we return the middle value, and if at the end of the while loop we don't find the middle value, then we'll just return none, or you can just return -1, whatever your requirement is. So I will just return none. Now let's run the code and check if it works. So I have this example case. We have an array from 1 to 10 and our target is 9. Now 9 is located at the 8th index, and I'm calling my function by providing the array and the target. And if we run the code, as you can see, we got our answer as 8, meaning the code works perfectly fine. So that was binary search. See you in the next video.